It's out of battery, so I have to speak loudly. So this is where we left off. So yes, we're videoing. So this is the circle Willis from the side. Right now, the one that I think is really easy to see the circle of Willis for is the circle of Willis from above. Okay, so move on to this one, if you don't mind. And what you see here is this is the guy's nose, right? These are two ears. So this is, if you have a camera and it's looking down on my head, that's the position. So nose is in front, ears are on the side. Okay?
I love this drawing.
You love it? Why?
It is just so silly. It's the best way.
How do you draw the top of your head? I mean, this is the best I can do. It's a way to go. Okay, so sticking with our color scheme, right? Circle Willis from the above. If I tell you that, okay, I got to do this again. This is the right side, and this is the left side, right? So the nose is in the middle. This is the right side of my head, and this is the left side of my head. So if I told you there are two major arteries that come up to supply the anterior portion of the brain with blood, one comes up here, and then the other one comes up here. Which arteries are those? Left and right? What? Those are your internal carotid. So this is going to be my right internal carotid. And then this is going to be my left internal carotid. Okay. And I talked about there being two main arteries coming off the internal carotid. These branches happen at about the level of the eye, which we're going to say is here. Coming forward off the right and off the left sides. Which artery comes forward and flips over the corpus callosum? Anybody remember? Good. That's going to be your right and left anterior cerebral artery. So here's your right ACA, and here's your left ACA. Okay, everybody see where we are? And we also have, coming off at about the level of the eye, two other major arteries, one on each side actually, coming out toward the ear. Okay. Which ones are those? Anterior circulatory system. Internal carotid comes up, forms the ACA, and then coming out toward the ear is the MCA. Correct. Middle cerebral artery. So this is going to be my right MCA, and this is going to be my left MCA. Is everybody with me? See where I am? Okay. All I've done is we've been looking at things from the side and the front. Now we're just looking down. I think it's a little bit easier to see this way. Kind of visualize. Hard to draw in 3 dimensions. Do my best.
Doing great.
Okay, well thank you. Now, that's the anterior circulatory system. We talked about that one a bunch. Now coming down here, we have two vertebral arteries left and right come up, about the level of pontomedullary junction. Bless you, they form one major artery here. What's that artery called? That's the basilar artery. Good. So here's your basilar. Okay, and then coming off the basilar artery, just above the level of the third cranial nerve, two shoots are formed to come back here and supply the occipital lobe, which you expect to be back here, right, with blood. Which are those? PCA, good. Posterior cerebral arteries. So this is your right PCA, and then this is going to be your left PCA. Okay? Everybody with me? See what I did? All I did is I just drew the anterior circulatory system first, and the vertebrobasilar in the back in green. Again, keep the colors the same. Okay, internal carotids come up, ACA flips over corpus callosum, MCA comes out toward your ears. In the vertebrobasilar system, vertebral arteries come up, form basilar, basilar comes up, above the level of third cranial nerve, two shoots form out, PCA, left and right. Okay, PCA supplies the occipital lobe, the area of the occipital lobe with blood. Got it? Now, circle of Willis. Where does the anterior communicating artery reside? Which arteries do I connect with the anterior communicating? Yeah, the ACA is good. So my anterior communicating artery is going to be here. It's an artery that sits there and connects my anterior cerebral artery. So let me label that. This is my anterior communicating artery. Okay, does nothing more than connect the two ACAs, and by doing so, it is a single artery that connects the left and right circulation of the brain. Now, I also said there's another pair of arteries that come off the internal carotid and connect the internal carotid with the PCA. Right? Which arteries are those? Right, so we have the right posterior communicating artery, and then we also have left posterior communicating. Now you can see the circle of Willis. There it is. This is the circle right here. Okay, so you have one artery, the anterior communicating artery, connects left and right halves of circulation to the brain, and then you have two paired arteries, or a pair of arteries, left and right posterior communicating arteries, connect the anterior circulatory system with the vertebrobasilar system. This is important because if blood supply is cut off in a major area, you can still continue to receive circulation minimally. So that's why it's so important. You connect left and right sides and anterior to posterior. Yeah?
Are the communicating arteries like supplying any tissue like in between the anterior and posterior circulatory system, or are they just connecting?
They're just connecting. They're not, yeah, we're going to talk about territories of arteries here in a minute, but yeah, they're just connectors. That's all they do. They're responsible for connecting things. Any other questions? You see the circle of Willis now? Does that help make more sense, Morgan? Okay, now you got it? Okay. Yeah, I think it was the vertebrals that were confusing you. So, okay. All right, let's go ahead and move on then. That's circle of Willis from above. Now, let's talk about ACA and PCA territories. You know, I can bring it up a number of different ways, but so if you think about it, does anyone know if I have, let's say I have a stroke, or I've had a stroke that's affected the right side of my brain, what side of my body would I expect to be affected? The left. Good. So cortical issues are contralateral, right? So anytime I have a stroke, if I have a stroke on the left side, or a part of my brain is affected on the left side, I would expect signs and symptoms of the patient to be on the right side. Okay, just an important thing to know. So it's contralateral. Having said that, let's look at the ACA and PCA territories. Ooh. And what you see here, this is a sagittal section, as it says. And here's the corpus callosum. And let's go ahead and label some of these things. If we had to think about regions or lobes of the brain, what's this thing back here? Yeah, that's my cerebellum. Okay, and this lobe in the very rostral portion of the brain, yep, that's my frontal lobe. Okay, then I have, let's say there's a central sulcus here. What's this lobe back in here? Parietal, good. Okay, the very back lobe, that's going to be my occipital, good. So we talked about how the circulation gets there, how blood gets to different parts of the brain. Now look, we're going to look to see what parts of the brain each of these arteries supplies blood with. Okay, so back to the original anterior circulatory system, I have coming off the common carotid, the internal carotid artery travels straight up to the brain, and I'm going to draw that here. Okay, travels straight up, and that's going to be my internal carotid artery. So let's see. So if I had to think about it, so if this is a sagittal section, which is cutting me right down here, what you're looking at now is the left side, is the part that's left. That's residual. Sorry. So you have the left side that's residual. So I've taken the right side of my brain and I've just removed it. That's what you're looking at. So this is going to be the left side. So when I'm drawing this up here, this is going to be my left internal carotid. Okay. That's my left internal carotid. And my left internal carotid is going to travel all the way up to about the level of the eye, I said, and it's going to flip over the corpus callosum just like that. And what's the name of that artery that flips over the corpus callosum, comes off the internal carotid? ACA. Correct. This is going to be my left ACA, my anterior cerebral artery. Okay, and then at about the same level, coming off the internal carotid, I have my left MCA that's going to come out through my ear, and I'm going to try and represent that as like a dot going back. The MCA, like I said, is going to supply most of the lateral surface of the brain, so we're not going to see any action from it right now on the medial surface of the brain. Okay, so just thinking about the left side. Now, if I have to say which areas of the brain that the ACA is responsible for, I'm going to come off the ACA and I'm going to draw a little, it's going to supply most of this medial surface in here for the frontal lobe. And in addition to that, it's going to flip over to the opposite side. So it's going to flip actually over a little bit onto the lateral surface of the brain. We'll see that when we look laterally. But in general, know that ACA is going to supply all of this area with a little flip over to the lateral surface too. Okay, so this just represents that the ACA sends off shoots that supply all of this area, all this medial surface of the brain with blood. So this is all ACA territory. So the majority of the medial surface of the brain is going to be ACA. That's both frontal and parietal. Everybody see what I'm doing there? This ACA's got all that territory. Now, I talked about before the basilar artery, and I'm just going to start with basilar here. I know that it's coming from the vertebral, right? So you have left and right vertebral. But here, let's draw that. What the heck? Here's my left and right vertebral coming up, and then at about the level of the pontomedullary junction, which I'm going to say is about here, you come forward and you're going to make the basilar artery, And since this is only the left side, I'm just going to show the left PCA that comes back here and supplies the occipital lobe with blood. So let me label that. This is going to be your basilar. Okay. And this right here is just your left PCA. We're only showing the left because I've cut off the right. Okay. Just left with the medial surface. And that's the inside of the left side. Everybody see where I am? So, as far as the portion of the brain that the PCA supplies, it's going to have, as I said before, all of this occipital lobe in here. Okay. And it's going to also have just a little bit in front of the brainstem, not very much. Let me label that. And this is, as I said before, this is your corpus callosum. I just wrote corpus callosum. That's that major conduit of white matter that connects left and right halves of the brain. Myelinated axons. Okay, and then what you're left with here is just an area where we talked about the thalamus. There's going to be basal ganglia, lots of different nuclei in there. For the purpose of being a PT, you don't have to worry about what supplies that with blood. That's not as important. You know, in general, some stuff comes off the MCA that supplies. There's a little bit supplied by the PCA and ACA, but no detail is needed. Okay? Questions about that? Is that? Yes. Nadia.
Supplied by the ACA?
No. We're going to look at the temporal lobe in a minute. Okay, well, all we're looking at is the medial surface of the left side right now. So this is going to be the medial surface of the brain. The next one, we're going to draw the lateral surface of the brain, and we'll see what supplies the temporal lobe. The MCA and the PCA in general supply the temporal lobe. Yes?
So are you saying that these, I guess looking specifically at the ACA, that's going to be kind of in that longitudinal fissure then, right on the outside?
Mm-hmm.
And then those other arteries are kind of wrapping it around?
Yes.
Okay.
Yes, they're wrapping around. That's really important. We're going to see why that's so important here in a minute. That's an important part. Does somebody else have it? Spencer, did you have your hand up? Or no? Clayton? No. Okay. I thought I saw a hand up, but maybe not. Just a scratch, maybe. Okay, does everybody see where we are? This is an important point. So the middle part, the medial part, is mostly ACA and PCA territories. The basal ganglia and thalamus in the middle, don't worry so much about that. Now, for Nadia's question, we're going to move on to the lateral surface of the brain, and that's the next picture. Yes. And this is going to be your ACA, PCA, and MCA and ACA territories. Okay. Like I said, now what you're looking at is, let's make this, yeah. Okay. Now what you're looking at, if I'm standing up here, you're looking at the outside of the right side of my brain. Okay, so this is that boxing glove thumb, right? This is going to be your temporal lobe right here. This is your temporal lobe. Let's go ahead and label that. What the heck? Lots of stuff to label here. Let's say that this is your temporal lobe. What's this lobe up here in the rostral portion? Frontal. Let's go ahead and pop that guy in there. So I said that there was a really important sulcus to be aware of here. Separates frontal from parietal. Does anybody remember the name of it? Yep, that's your central sulcus. And then behind that's going to be your parietal. And then it's going to be your occipital. Okay. That's where we're starting. I also want to draw in in front of the central sulcus, there was something that I said that was involved in motor function. Does anybody remember the name of that? Yeah, that's your precentral gyrus. I'm going to draw that in pink because I like to keep the red there, but I don't want to. This is going to be your precentral gyrus. And then inside your precentral gyrus, you had this little homunculus guy. Remember, he was standing on his head. There's his head, there's his body, and his feet actually flip a little bit over the side. I remember saying that the other day. And then his hands, his arms are right there. Okay, so that's your precentral gyrus. Is involved in motor function. In addition to your precentral gyrus, you also had your postcentral gyrus, just behind the central sulcus, and I'll draw that in here in green. And your postcentral gyrus also has a homunculus. We talked about the other day with the feet flipping over and the arms coming off. Okay, so precentral gyrus, primary motor cortex, postcentral gyrus, primary somatosensory cortex. So remember that from Monday? Good, good. Now, we talked about that MCA, and for the purpose of being able to visualize this, I'm going to choose to make the MCA in blue, just because I need a different color. And as the MCA migrates out, so internal carotid comes up and it comes out about the level of the ear, what happens is the MCA actually appears coming through here in the lateral fissure. It comes straight out to the side. Just goes right through the brain, comes out the lateral fissure, and makes an appearance. Okay, does everybody see where I am? This is going to be, I'm going to choose to use blue for MCA. And then this is the right side of my body, so this is going to be the right MCA. I don't know that that's as important right now. So that's going to be my MCA. Everybody got it? See what happens? So the internal carotid come all the way up. Let the MCA shoot out to the side. The MCA actually travels through the lateral fissure, makes its appearance on the lateral surface of the brain. It has a huge amount of territory. Okay? What happens with the MCA is the MCA supplies all of this area.
Leave some brain.
There we go. Oh, you see what's happening now, huh? Okay, good.
I did pay attention.
Good. I'm sure you did. I'm not saying you did. That's your MCA territory. Huge amount of territory. It has the majority of the lateral surface of the brain, right? Now, how about that ACA guy? Remember I said on the medial surface it comes up and then it flips around. So what happens is you actually start to see the appearance of the ACA here. So it supplies just a little bit of the lateral surface of the brain as well. So this is just, it's continuing from the medial surface and it's wrapping around, like I said, to the outside of the brain. This is your ACA. That's your red. Okay, so you got your MCA supplying most of the lateral surface, but the ACA supplies just a little bit of the top. Just wraps around from the medial surface and gets a little bit. Okay, and then your PCA, we'll keep the PCA green because that's been here. The PCA gets the rest. So the PCA territory is going to be, so Nadia's question was, the MCA is going to take half of the temporal lobe, the PCA takes the other half. Okay, the green is, I'm going to call the green the PCA. posterior cerebral artery. Okay, it's going to get the bottom half of the temporal lobe and all this occipital back here. Okay. Does everybody see that? This is really important because if I ask you if a person has a stroke that's affected their anterior cerebral artery, do you think they're going to have more problems with their arms or their legs? I hear legs. So if a person had a stroke that affected their anterior cerebral artery, look up here. Do you think it's going to affect their arms more or their legs? Legs. That's the point of this. If a person had a stroke that affected their MCA, do you think their arms or their legs are going to have more problems? Arms. That's it. That's the big picture. That's what you see here, right? MCA territory. Yes, and actually trunk too. But ACA, mostly legs. MCA, mostly arms. Okay? Thinking about classic presentations. And for a person that's had a stroke that affects the, 1 minute, the right ACA, is their right leg or left leg going to be weaker? Left? Yes, Sam.
So I think I was going to ask after class, but I guess I should ask now.
Ask now.
So the point of the homunculus is to show, like, in that pre-central and post-central gyrus, like, top portion is more in control of the legs, and as it works down, that's where it's going to more interact with the rest of the body. Is that correct?
Yeah, so the
Gotcha.
homunculus
Okay,
is,
I looked at it over the study guide, or the instructional objectives last night, and I was like, I need to ask about that.
Does that make sense though now
Yeah,
that
I
you
think
think
so.
about it? Okay, because that's where it's a somatotopic representation of the body. So neurons that control the lower extremity are going to be higher up than that control the upper extremity versus the face.
Gotcha.
Okay, and that was what I was trying to get at with the
Okay,
thing. So
now I
yeah,
get it now.
Ben.
So since the PCA doesn't go into the homunculi, what would it affect?
Vision. We will get into how it affects vision and what kind of vision things can happen when you do affect certain areas in the visual tract, but that's many weeks away. That's toward the end of the course. So yes, if a person has a PCA, a stroke that's affected the PCA, I'm thinking they're going to have trouble seeing in some way or another. Does that make sense? That's what you see. That's simple. Okay. Other questions? Is it clear? Can you see what happened? Okay. I think how to do this.